Bismillahirrahmanirrahim. Start with the greatest name of Allah, who is most kind and merciful. Myself, Muhammad Salman Malik, student of CS 2K19 from Sun University campus, Ladakh. I am here to present my topic. The topic name is Regula Falsi, and that is given by Sir Sanaullah Bhutto. So let's go and start the topic. Regular falsi method, or the method of false position. It is a numerical method for solving an equation is one unknown. It is quite similar to bisection method algorithm. It is one of the oldest approaches. It was developed because the bisection method converges at a fairly low speed. In simple terms, the method is the trial and error technique of using test false values for the variable and then adjusting the test value according to the outcome. This is sometimes also referred as guess and check. What is another name of regular falsi method? Another name of regular falsi method is falsi method. That is also known by false position method. It is a called false position method because of its behavior, as we have discussed in previous slides. That it is also refers as to is its guess and check point. So we do in problems guess and check. Because of this, its name is also false position method. Interpolation Interpolation is the approach of this method to find the root of nonlinear equation by finding the new values for successive iterations. In this method, unlike the second method, one interval always remains constant. So how to solve regular falsi method? So first of all, the regular falsi method, we have to estimating the roots of polynomial means we have to put the any number which we have given in some, we will put in x. A value of x replaces the midpoint in the bisection method and serves as the new approximation of a root of f of x. The objective is to make converge faster. So I have written the formula of these regular falsi method. So first of all, we have seen as the previous slide f of x, and we will put number which is given in problem. So here we will put the number which is given in problem, and this another problem, oh sorry, formula which we have to use after solving this point. So we will discuss later on it. First of all, we are understanding that this is the a and this is a function of b. This is the function of b. So for remembering this formula, remember a function of b minus b function of a, function of b and function of a. The function of b is dividing, so also we have to put this on under this. So we are coming to our topic, regular falsi method. So first of all, f of x, we have a problem f of x x cube minus 2x minus 5. 2 and 5, that is the problem which we have to solve, and we have to find a root between 2 and 3. We have to find a midpoint which do not comes in minus and do not comes in positive, means it comes in positive but nearer than negative. So we have taken 2 and 3, the function of 2, we put 2 in this formula. So 2 cube minus 2 into 2 minus 5, it becomes 2 into 4 minus 5 means minus 1, and 2 into 3, that answer comes to minus 1. So also here its answer comes 16. That is greater than 0 and that is less than 0. So we are going to find the nearest number that I have already told. To find the nearest number then to negative, which can come in positive. So we have taken 2.5 here, so its answer comes also in positive 5.6.25. But we have to find the nearest number to negative, so I have also solved 2.3 q minus 2 in formula. We have to put these points. We are going to the nearer one to 2 1, and we have to take this formula and we will put these numbers into it and we are getting the answer. So also I have put 2.2, but it was a little bit away, so I have put 2.1 here. 2.1 cube minus 2.2 under 2.1, and the answer I have got here 0.061. That is also greater than 0, but it was a nearest number to minus 1, means into negative. So let's move on to the next slide. So from here we have to move forward to our second formula, that is a function of b minus b function of a, b function and minus a function. Let us take a is equal to 2, that we have taken the a, we are taking this a and this to b. 2.1 is b and minus 1 the function of a, minus 1 this is the function of a, okay, and 0.061 this is the function of b. We are assuming that this is b and this is a. The function of a is minus 1 and the function of b is 0.061. So here we are. So now we are putting our values in this formula, a 2 and our function of b is 0.061 minus 2.1 and the function of a is minus 1. So also here the b function and the a function, okay. So now I have divided the multiplied it, also multiplied it and then subtracted and also these two, and I have got this 2.222 upon 1.061, and then I have divided it and the answer I got 2.094. So here it is a, we are assuming that it is a. Now we are finding the function of a. So the function of a is 2.094. We are putting again into the formula this. So 2.094 q minus 2 and 2.094 minus 5. So the function of a, I got the answer minus 6.153. So that was our x1. So again we are finding x2. So our x2 is 2.094. The a we have found here 2.094, and the function previous function of b is 0.061 and 2.1 the b, and minus 6.153 the recent one function of a. So here is also the function of b and that is the function of a. So I have multiplied them, and the answer I got multiplied and divided also. No, sorry, I have multiplied them and the answer I got this, and I have divided it, and the answer I got is 2.099. So we are assuming that this is B. So let's move and make it to the function of B. 2.099, let us find B. So that will be put into the formula as previous. 2.099q minus 2, 2.099 minus 5 is equal to, the answer I got is, the function of B is 0.049. So again we will put the new values as same. So 2.094, the A, and the function of B which we have found now, 0.049, and 2.099, the function B we have found here, we are putting it, and the function of A which we have found in previous slide, in previous problem. So then we now we have to multiply them and subtract. The answer is 13.017 upon 6.202, and then I have divided them. The answer I have got 2.098. So again we will put into the function. The function we will got 2.098 and 2.098 cube. We will put into the same formula, and then I have got 0.074. So we will again and then again put into the x3, means I have done the x3. So again we will put into the x4 and continue or this process, put into the formula, in this formula, and then again change into the function in this formula until we have got the same values, like here we have got 2.099 and 2.098. These are little bit nearer but not same. So we will try until our answer becomes same. So that was regular falsi.